Number 1?
We talked about one after the quiz.
Yeah, we have to.
Oh, yeah. One we talked about, yeah. Please. I mean, if somebody gives me that as an answer for something, for a function that does certain things, why do you think you're going to lose a lot of points?
It's not a function.
It's not a function. I mean, so you failed on the first thing. Draw a function. No. I'm sorry I'm being so cruel, but these are the things it just should hurt. It should hurt to do this. It should actually hurt a little bit, like scratching your nails on a chalkboard or something. It should hurt. No, not a function, no. So piecewise are defined in pieces for a reason, so they don't overlap each other. So you're not saying this, well, where was he at 2 o'clock on Tuesday morning? He was on the corner of 48th and he was over there at Tulsa at the bank. How the hell did he do that? So functions have to make physical sense. You can't be in two places at once, unless you can, in which case, teach me. I want to be your student.
How the tables.
Huh?
How the tables were turned.
Oh, okay, yes, exactly. The teacher becomes the student, yes, exactly. All right, so, anything else? That's all the quiz, right? We just did all three. So, do those corrections for tomorrow. Just to remind you guys, even if you got, I can't remember what the lowest grade was, like 40 or something. Even if you got a 40, if you do all the corrections, you miss 60 points, divided by 4 is 15, you can get 15 points back. And then if you do better on the test, if you did all the corrections right and got all the points, it can become the same grade as your higher test grade. So technically, you could get a 0 on the quiz, do all the corrections, get them all right, and then get 100 on the test, and your quiz grade is 100. Do you understand? This is why you don't give up hope. Quizzes just say, oh shit, you should have known this. Right? And then you go, oh shit, let me find out. And then on the quiz, you're not going to make the same mistake. I mean, on the test, you're not going to make the same mistake. Tests are heavier weighted, more important. Hello. Okay. We good? Shake it off?
Wow.
No, don't start singing, please. I didn't mean to open that window. All right, so what I want to do is to do something a little bit more concrete that flows back into that drawing the derivative that we were doing yesterday. And it's a nice review of the limit definition of derivatives. So somebody help me out. What is the limit definition of derivative? So what symbol do we use for the derivative? Yeah, so given f of x, the slope of f of x at any point is given by f prime of x. And what's the limit process? Yeah, good. So limit as h goes to 0. No a's anymore, right? That's all right. I want my answer to be a function in its own right. So I don't put an a, I don't put a specific number in. I just let it be any x I want. So if I want to slope a 7, I can just put 7. If I want to slope a -1, I just put it a -1. I don't have to redo the process over and over. So don't worry, after this first test, I'm never going to make you do that again for a test. We might do that in class to explain something. But we're going to let go of the limit definition after this first test. I see too many people doing this, and we don't know that shit yet. Right? That's basically another way to say this, but we do not know derivatives yet. That's a quick way to lose all the points. So, let's do this function here. Oh no, let's make it a cube. X cubed minus 9x. X cubed minus 9x. Let's apply this idea to it to figure out what f prime of x is. And I know, if you already know the derivative, it's just too damn bad. I know you know the answer. Do it and see if you get it. Now, real quick, a little side note. Do you guys know this? Pascal's triangle. Do you know what it's used for besides, look at the pattern?
Polynomials, right?
Yeah, expanding polynomials. Yeah, exactly. So x plus h squared would be x squared plus 2xh plus h squared. Notice how all the x's 1 less x, 1 more h, 1 less x, 1 more h. And where do the coefficients come from? 1, 2, 1. Why is this important? Because am I not going to have to do x plus h cubed? I'd really rather not multiply it out, sit there all day. So what's x plus h cubed? I'm going to use this row for my coefficients. All the x's first. Coefficient of 3, 1 less x, 1 more h. Coefficient of 3, 1 less x, 1 more h. Get out of there, cubed. Coefficient of 1, 1 less x, 1 more h. Done. There it is. If I had to do x plus h to the fourth, blah, 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 blah. Right? Fifth, you just 1, 5, 10, 10, 5, 1. You just keep adding. It's neat.
Wait, how did you do that? Adding?
Sorry?
How was the adding thing?
1 on the outside. 1 plus 4 is 5. 4 plus 6 is 10. That's how I got 4 here. 1 plus 3 is 4. 3 plus 3 is 6. 6 and 4 is 10. Blah, blah, blah. And you can just keep going until you get to the one you need. Some of you guys might realize it's related to probability also, combinatorics. If you don't, just let it go. Sorry. It's related to counting, which is related to probabilities. All right, so how does this come into play? Because I'm going to need that there, right, for this piece. So what's f of x plus h? It's x plus h cubed, which you figured out here, right? Minus 9 times x plus h, because that's what I'm plugging in. All right, so now we can put that thing together, right? Are you guys with me still a little bit? So you can do higher powers using this, or you just have to do it over and over, foil, 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 foil. Okay, maybe. So what do we got here? We got the limit as h goes to 0 of this business minus this. Are you guys with me?
Yes.
Right? So we figured out this here, minus 9x minus 9h. So we got x cubed minus 9x minus 9h. Minus, I have no room left, minus f of x, which is, so like that, get all over h. Okay, let me let you guys do this. So you guys with me? So where's this? Here. Where's this? Here. Just plug and shove. Just plug in there what it is.
Plug and shove.
Plug and shove. Let me stop there for a second. What's up? I see some pained expressions. What's up? Is everybody cool with me here? Even if you can't do this, you can still write that 3 times in foil 4. Right? Notice what happens. What happens to the x cubed? So what's the highest power I'm going to be left with?
Square.
If I would add a 4th power, the same thing would have happened. I would have been left with the next thing over the cube. That's related to that first rule we learned, which is the power. If it starts off as a 4th power, the derivative will be a 3rd power. So forth, so forth. It'll happen no matter what power I make. It's going to happen that way, isn't it? So the x cubes cancel. I'm left with the x squared is my highest. And what else cancels? 9x. Thankfully. Everything else I have left, it has an h in it, which tells me I'm on the right track. So then how can I write the limit as h goes to 0? Cancel an h out of everybody. So this will be 3x squared. I love it. So just kill an h everywhere because you're going to cancel along with that guy. Let me stop there. So this is section 2.8. This is also section 2.7. Section 2.7, you put a number in instead of an x. But, you know, that's silly, really, to be honest. Right? I wish they would make 2.7 go away. And then if I let h go to 0, what am I left with?
3x squared.
So look at the original. What does it look like happened? Looks like the 3 came down and it became a 2. And what is this? What power is this?
1.
So it looks like the 1 came down and it became a 0, because what's x to the 0?
1.
Yeah, so that seems to be maybe a rule that later we're going to make into an actual rule and use, that you cannot use right now, man. All right, so everybody, that is the process, the definition of the derivative process to find f prime. You have to do this in section 2.8 for sure. Section 2.7, same thing, except you put a number in for x. So what if I wanted the slope at -2? What would I do? No, we've already done the work. Yeah. what does this mean? The slope, I love it. Derivative is the calculus name for slope. So if I want the slope at -2, I plug a -2 in, and what do I get? 3. All right, let me do one more thing with this, and then I'm going to take it back to what we did the other day, right? And yesterday. What point does the function go through? What's the point that the function goes through for a value of -2? What is f of -2? No, that's f prime of negative, or maybe, I don't know, I haven't done it. F of x, I think I erased it, sorry.
X minus 9x.
So -2 would be -8 plus 18, 10. So can you find the equation of the tangent line at x equal to -2?
Yeah.
What do you need for the equation of a line? You need the slope. We got. What else do you need? You need a point. We got. Right. So don't let that's algebra. In algebra, I can say find the equation of the line that is perpendicular to this line. So you got to find the slope first, right? So how do we find the slope? Using the limit definition of derivative, right? But once I got it, it's the same old shit. So how do you figure out the equation of the line? Or you can do you can do y minus y1 bullshit. But just to get there more directly, when y is 10 and the slope is 3 and x is -2, now I can figure out what b is. Right? You guys ever done it that way?
Yeah.
You can do the y minus y1 way, but it's too much shit. So I get b is 16. So I get y equals 3x plus 16. So that would be the tangent line to this curve at x equal to -2. How are we doing? Is that okay? That whole process. That's section 2.8 in a nutshell. When we get to chapter 3, we're not going to have to do this anymore. We're going to develop shortcuts and make them into rules for derivatives of different functions. Thank the gods. Right? All right. Okay, so what we did, let me summarize what we got. For a function that is x cubed minus 9x, we got this derivative to be 3x squared minus 9. Okay. Just file that away for a second. So we got what they want from this here?
Yes.
Okay. More than you wanted. Oh, let me put, what was the tangent? We got this tangent line, right?
Yes. Yeah.
All right, we'll look at that later. All right. All right, so, tell me real quick. Anybody know what the roots of that are? What are the roots of this? Just to try to graph it real quick. 0, I like it. Good. Yeah, -3 and 3 I love, because it would be x squared minus 9. I didn't ring about. So you get -3 and 3. Multiplicities through each would be 1, so it's going to go through each, right? End behavior, oh shit, why are you bringing this up, Jeff? End behavior would be like that, right? So it's going to be roughly, see how I cover my ass? I don't put a y scale, just right now. So in this kind of problem, that's what I'm going to give you. I'm going to give you something without a y scale, so you don't feel like you have to be exact. So remember, this is what we did yesterday, trying to trace what the slope looks like, right? What the f prime would look like. Less analytically, more conceptually, which is always painful, I understand. Yes, sir?
I forgot. How did you find the end behavior for that?
Oh, the biggest degree is cubic, so it's going to look like a cube on the ends. So it's going to look like that, right? I think that looks right from your perspective, yes? Okay. How are we doing so far? Is that cool? So there's a lot I did very quickly. It's all multiplicity and all that kind of shit, but you should be able to graph that. A real quick sketch. How do I graph f per? So this is f. I want to graph the function so that every output on this function represents the slope. So right now, what did I graph in purple? Every output represents what the function does to an input, right? What the function directly does to it. Is that so? If I put a 3 in, it does this shit to it, and then I go, I get 0. You with me? So I want to draw instead a graph of what it would do, of the slope at each x. So what's the slope of the function? Where can I start? Where's a good place to start? Like we said yesterday.
On zeros.
Yeah.
I definitely know the zero slopes. Those are easy to see. Where's the slope 0? About here, right? Roughly. And about here, right? Should be symmetric, but my scale sucks. It's too bad for me. You guys semi with me?
Yes.
Alright. If I would have been more careful, this would have come out nice, but look at that scale there. Oh, too much. You're okay. Where else am I trying to go? So, I know it has to go to 0 here and 0 there. Where is this thing? What's happening here? What kind of slope is this?
High slope.
Yeah, if I go further down, it's going to get really big positive slope. Do you guys see that? So I want to put a point. So like right here, I could do, technically, I could get the scale, I could draw my approximation, I can count rise over run. Alright, that's not what I want here. That's a separate kind of problem. This problem, I just want you to put the point up here somewhere because it's freaking big positive. You understand? I don't even know the scale here. I just want to get the idea of it. Right? That's what's important here, is the idea. So it's really big positive slope. I know the function is down here, but that's what the function does to an input. I am now graphing what the slope of the function is at every point. That's what I am graphing right now. So what's happening as my x's go this way, what's happening to my slopes?
It's getting lower.
They're getting smaller until they hit 0. Now what happens after that?
So it's going negative.
Now my slopes are negative.
Yes.
Until it hits a point somewhere in here. What's special about that magic point in there?
So maximum.
The most negative, right? So again, the black line I'm drawing represents the slope of the purple one, right? So somewhere in here it's the most negative, and then too bad for me. Right, so it's negative, and then what's happening after it gets through the most negative point? It must be getting less negative, or else I wouldn't have called it most negative. Right? You guys with me? So most negative in here somewhere, and then it's less and less negative until it's 0 again. So how am I drawing this? Well, it's negative slope getting more and more negative, and now it's getting less and less negative. So again, it matches up with those points, which is one reason why you put them there, so you know if you don't hit them, you're like, oh shit, I did something wrong. Right? You're supposed to hit it here, because where it's flat. And now after this point, what happens to the slope?
Positive.
Now this is where people start. Now see how it's going to kind of mimic that? Well, of course it is. If it's a really big positive slope and it's getting more, then that's going to look the same, isn't it? It's just coincidental that the function is doing what the slope says it's doing too. It's just coincidental. That's where people start to believe, oh, I'm just following the grid. No, you're not. No, it's just coincidental that it's going like that. You guys, how's that? Is that better? And how does that relate to what we did here? Well, what's that look like? Let's see if I would have had my scale better. Yeah, and let's be more specific. If I try to factor this, you guys cool with that?
Yeah.
And rad 3 is like 1.7 something, I think. You guys kind of with me? So about 1.7. That looks right, and this is where I had my big ass scale. Are you with me? But it didn't have to be perfect. It didn't have to be perfect, but I just wanted, I didn't even really know what was going to happen, but it's kind of nice to see if I would have made my scale better. That could have been a 1.7. It looks about right, right? It is parabolic, and it's got, this would be -9 if I wanted to make a scale there. You guys kind of with me?
Yes.
A little bit? So that's the connection. That black line is what I would get if I did that whole limit process. That's the function it represents, because that function represents the slope at every point. This function, stay with me now. This function represents the output of the function itself. This is a new function. It represents the slope of that original function at every point. So how can you step back and make sure it makes sense? Where's it decreasing from here to here? You better be below the x-axis then, because that's supposed to be negative slope. That's a real quick check you can make to make sure you got at least that kind of thing right. How are we doing? Is that better or worse? Or you just killed two birds with one stone, sort of? The whole limit process and how it leads into an understanding of what this is. All right, hopefully. Okay, now I'll open it up. Now I've taken most of the time with that, but that was good. We just needed to see that anyway. Anything specific from practice test or homework? 7 on the practice test?
Yes, sir.
I gave you guys the answer key, right?
Yep.
Yes.
Does anybody still need the answer key?
Let's see.
Yeah. Oh. That's, I think I gave away all my actual copies of the thing, but oh well. Is there any questions from... I know how you feel. You're all like, number 7. So most of you guys are like, dude, I don't have time for this, man. But still, I want at least... Oh, yeah, okay, the epsilon delta stuff. Okay. Let me put it up. Just so we don't... all right. Epsilon delta, obviously, I think you can tell it's kind of important to me. But it's not... It's going to be one problem. So, I'm going to be honest with you. You got to weigh that, right? So if you're completely lost in epsilon delta, let it go. It's okay. It's not going to kill me, right? The further you're going into math, though, the more you want to buckle down and get it now, because it's going to help you like crazy later. You'll just be that more familiar, that more comfortable with this kind of thing later. So a little quickly here. It's number 7 on the practice test. And I trained all the tutors last Friday on how to do this. So given epsilon greater than 0, we want to show that what? We can find delta greater than 0 so that what? So basically, remember, what's the idea behind it? To get really, really close to my inputs, my outputs have to get really, really close to the limit. If it really is the limit, that's got to happen, right? The closer I get to my input that supposedly has that limit, it better be freaking getting close to the limit, or else it's not the limit. So on the back end, it totally just makes sense. It's just how you have to be, how formalized it has to be is freaky as hell, and I understand that. So that if I get really close to my input, is that cool? X minus negative 2. So that says I get really close to my input of negative 2. That's what that says in English. Absolute value is distance. Let me let you absorb that for a second. When I get really close, arbitrarily close, or this close to my input of negative 2, then my outputs get arbitrarily close to what the supposed limit is. 14. Are you okay?
I'm just trying to read what you wrote.
Oh, I'm sorry. Listen to what I'm saying. I can't. Let's see. We want to show that we can find...
What is the W that you...
Oh, we want to show. So let me, I'm gonna write what would teacher show? Yeah. What would teacher show? Teacher. All right, sorry. So what's the side work I do that feels like it's cheating later? I start with the answer, basically, right? Which feels like you're cheating, but you're not. It's construction proof. I'm going to construct what I need. So I put f of x minus 14. And I say, what has to happen for that to be true? So what am I trying to capture now? What am I trying to have show up?
X plus 2.
Yes, exactly. I want to. If I can make that show up, I know what to make epsilon be. So let's see what happens here. So I get, if I do this, what do I get? And what's the absolute value of negative 3x by 6? 3x plus 6. Oh, you killed the negative, right? Yeah. And then what can you do to both sides?
Divide by 3.
Divide by 3. I like it because it's positive. So what do I have to make delta equal then?
Delta.
Epsilon over 3. Right? Some of us knew that already because the slope is negative 3, but it's all absolute value. That's the idea. And now you just do all that in reverse, right? Given epsilon greater than 0, let delta be, so it's the proof, let delta equal epsilon over 3. Then when this is less than epsilon over 3, done. So it really is kind of true. I understand when you do the side work, you are done. I understand that, but not really. You constructed what you need, now go show it works.
So how did you set it up? Is f of x minus the limit?
Yeah, this is f of x minus the limit. And I want that to be less than epsilon, right?
And we want it to be a ratio. We want it to be, or we want it to be x plus 2, right?
Yes, we want to, given where I want to end up, if I can capture this on this side, what's on that side is going to tell me what delta has to be.
And we got that from the limit because it's -2. So it's
Exactly. So I want to be really close. So I want to be close to -2, right? So then that's going to be x plus 2. And close is captured by delta. Delta is how it's
so it's
close.
positive 2, then it'd be x minus 2 in the absolute value.
Exactly. It's x minus whatever. In this case, it's x minus -2. So
And
X plus 2.
21
yes. It hurt me to say that, and it hurts me to hear that, but I understand at the same time. Trust me, I understand.
There's a lot of steps right there.
Aw. Yes.
I was gonna say, then you just plug that into the delta and then go from there and like multiply.
Let delta, and then you say let delta. So, and now you got to do this. If this, bam, then that, bam, you're done. If you can show, given it, when this is true, that this is true, you've proven it. And we haven't done that yet, officially. We just kind of know what to make delta equal so that that will happen. All right, so that's enough of that. That's enough of that. Again, I don't want to spend all the time on that. All the 7 minutes left. Yes,
Are you gonna have anything on continuity?
of course.
I mean, like I think it's 2.5.
2.5.
Yeah. Number 12. Sorry. Yeah. Oops.
Oh, okay. These, they really are hammering this, and they is me, because I assigned this problem, but on one level, I just want you to realize it's the fact that what's got to be true for the f of x to be continuous at a. Let's start there. Not just f of x must equal f of a, then that would be a flat line. It equals f of a everywhere.
F of x has to equal f of a.
No, then it would be a flat line.
Is it limit?
The limit as x approaches a of f of x has to be f of a. And we know that's not necessarily true. A limit can exist and it can have an open hole there, of course. Because the limit doesn't give a shit what happens there. Continuity says it's got to go to where it looks like it's going to. So you don't have some big sinkhole to go around. I like it. So that's the idea of continuity. So this problem says, use the definition of continuity and the properties of limits to show that this function, show that that's continuous at a equals 2. Now you really got to just write a couple of things when you're done here. Every piece of that function is itself what? This, and this. They are all what's on their what?
Continuous on the domain.
Kick-ass. I like it. Each piece of this is continuous on their domain. So that function is continuous on its domain. You with me? In fact, what is the domain of this real quick? Anybody know?
0 up.
All real numbers, right? It's the cube root. Who gives a shit, right? Cube roots can handle negatives, and it's never negative anyway, so it's actually just being overly careful. Do we have to know that? No. But this function is continuous on its domain. Why? Because it's made up of combinations of continuous functions. Let me stop there for a second. That's using the property of continuity. And you're basically done. So at a equals 2, what's the limit? Does the limit as x goes to 2 of f of x, does it equal f of 2? Yes. Why? Because each of these is continuous on its domain, therefore you're allowed to plug the limit number in. Say something like that. That's what you got to say to me. Don't just plug a 2 in or something and say, it comes out to be a number. No. I need to see this. While I'm thinking about it, there was a section of section 2 on homework that asked you to explain what this would mean, something like this.
Yeah.
Don't use the word limit to explain limit. Does that make sense? That's why I'm crossing through limit and just getting a little crazy. What does this mean? Maybe I'll ask this on the test.
I
As x approaches 7.
As my inputs get close to 7,
Then f of x equals 4.
my
The output.
outputs get
Closer.
close to 4. There, that's. So I don't use the word to explain itself. Right? I love the whole thing. What's a ruby? It's a kind of gem. What's a gem? Oh, rubies. Wait a minute. The hell? Help me. That's actually from Little Rascals, actually. Yeah. If you ever seen that old show. When I was a little kid, I used to watch it. Yeah.
Back in the 20s.
Yeah, back in the 20s when I was a little kid.
Back in the corner.
Yes.
Is the practice test for number 11 in the answer sheet or now? You put a horizontal asymptote or any class, right?
Oh, yeah. Horizontal asymptotes, they only kick in when x gets really big. And to be honest, haven't we seen examples where it can go through its horizontal asymptote an infinite number of times? What kind of asymptote can you not just go through?
Vertical.
Because the vertical asymptote says you are not allowed to exist here. That's what a vertical asymptote says. A horizontal asymptote is, you better get close to this sometime. Right? You with me? In fact, we did exactly this to kind of start to understand delta and epsilon. Yeah, exactly. Okay. Yes?
You know the squeeze theorem?
Squeeze theorem. Let's do an arctangent one.